a very clever device. It's a kid's bubble one, but when you press the button, it produces hundreds of tiny little bubbles that, I'm just trying to get in the right direction here for the wind, that just fly for miles. And it does so continuously. It doesn't have some sort of dipping wand or anything like that. And the other interesting about it is that it's no spill. If you tip it upside down, you might get a drip out it, but it doesn't have free liquid. It's only sort of pumped in a circulating system. The little kitty down there, when she's in the mood, she just chases these bubbles all over the garden. But it's an interesting thing. Let's take it to bits and see what's inside. Back at the bench, and I have two of these bubble ones because I was so impressed with the first one, this is the oldest one, that I got from a shop called Waitrose, that when I went online saw they were selling these from an eBay seller, and this was a while ago. I don't know if they still sell them. I didn't see one in a search that I just did. But I was so impressed that I bought one as a backup. And this is good because this means we can take this one completely to bits. And I shall start doing that right now. So if I open it up, and I've taken the wires out here, the battery compartment and the switch are on this side of the housing. On the other side, we've got the liquid reservoir with a feed pipe that goes up to a pump, a peristaltic pump in here. And the output of that comes up to the bubble head. Now, draw the bubble head, what it looks like inside. I'm going to take this whole thing to bits though. There's also a drainage line. There's a fan here which blows the air up through the bubble head. But at the bottom of the fan, because of the way it works, excess liquid drains down, runs at an angle down here. It's quite cleverly designed to this drainage line and then drips back down into the container inside here. So it continually recycles the bubble fluid. It's actually got, for a bubble machine, it's got a very good seal. The refilling cap does seal quite tightly. It doesn't spill. This thing really is optimized for not spilling. When you tip it upside down, you don't get much out at all. It's very good that way. I shall lift this off here. I shall put the wand out the way. I'll just put them completely out the way. So if I open this up, the first thing that comes off here, off the end, and this thing was kind of glued together, but isn't glued together anymore because I used brute force and ignorance. This is a bubble producing head. I'll draw this in a moment because it's quite interesting how it works. And inside the body of the unit is the motor, which looks a bit corroded because, well, with any bubble machine, the bubble liquid always gets in. It's the way it works. The motor's a shaft out both ends. One end has the fan in it, and the other end is on a worm gear, which then drives through this reduction gear chain to the peristaltic pump. If I zoom down here, I'll show you the peristaltic pump. So if I lift this pulley off here, this cogwheel off here, and then this final cogwheel, which if I turn it, you'll hear a sort of popping noise as I turn it, because that's it trying to pump liquid. This is actually a very, very simple peristaltic pump. It's got not rollers, but just sort of rounded nubs on one side, and they rotate around pushing pockets of liquid through this silicon type hosing. And there's a little sleeve on this glued onto that hosing to stop it being dragged through completely. And that's what pulls the liquid up from the bottom here. Where is the hose? There's the hose glued on here to try and stop it getting dragged right round. Goes through the peristaltic pump and into the bubble head. And then when there's excess fluid, it flows down here into the fan housing itself and then through this little drainage hole. This thing was glued together to actually try and make it watertight. There was also a little thing here that's kind of sealed. I'm not sure what that was. Maybe just an option during manufacture. Not really sure. Everything seems to be fairly matched. The motor and fan diameter for a particular airflow and a particular fluid flow to actually match this, but there is a sort of drain back system. I'm going to wipe my fingers. I'm going to zoom out. I'm going to wipe my fingers. I'm going to bring in the notepad and we'll draw the bubble head because that is the most interesting bit here. This little bit here. It's worth mentioning that this pipe here pushes into the side. So there's a cone in here. I'll draw it. That's the best bit here. That bench is rapidly getting covered in a mixture of bubble fluid and grease because this thing was greased solid to try and give it some life. It's worth mentioning that, is this even going to run now? No. It's worth mentioning that even with fairly fresh batteries, it's a bit hit or miss whether it starts. It's really pushing it this motor quite hard, particularly overcoming the pressure in the peristaltic pump section. So it's not really suitable for rechargeable batteries, unless you get a version that's just a bit easier running than this one. They were both like that. You'd have to, sometimes it was sticking, you'd have to give it a wee boost to actually get it going again. I wonder how many people threw them out as a result of that. But anyway, I digress. Here is the airflow coming up from the air pump. And here is the head that we're interested in. So let's draw it as a slightly exaggerated big thing. It has little supports coming in from the side that support a cone that comes down like this. The bottom of the cone is open, so the air, as well as flowing up around the outside and out through the top, which is important because that air flowing through the top is what projects the bubbles out and lifts them off. Some of the air also flows in through the base here. The liquid comes in from the side through a pipe and into the side of that cone. And because you've got that mixture of the liquid flowing in here and the air blowing through, it forms bubbles. And those bubbles sort of move up to the top. And as soon as a bubble moves up to the top, where it can get caught by that airflow, that then detaches the bubble and blows it into the air. There are also some little slots, 3 of them mounted. There are three little slots in the cone. I don't know if you can actually see that. Let's see if we can zoom down to this. Actually, you know what? If I really wanted to do it, I'd bring it up here, zoom in, and then focus on this. Oh, that just completely failed. No, I'm not going to focus on this, am I? That's kind of not too bad. Can you see those little slots in there? And so you get the air flowing through the bottom of the cone, you've got the 3 little slots at the side, and then you've got the air channel round the outside itself. Let's focus back down onto the notepad because that's where we want to be right now. So I'm guessing that the reason for these slots is that if the liquid builds up beyond a certain height, it flows out these slots and then down into the pump where it goes out the drain at the bottom. But there is another possibility that maybe they're letting air flow in at the side. I'm not really sure because it all happens so quickly when it's running that it's hard to tell. However, I did, I should demonstrate that. I did stick a bit of pipe in the bottom and I blew through it. One moment, please. I'll just go and get that bit of pipe. I have the bit of pipe. I've attached it. I'm going to emulate the fluid being flowing in from the sort of reservoir by squirting some of this bubble fluid in here. It's going down the pipe, not to worry. This is just going to make a huge mess, isn't it, when I blow? But when I blow, you can see it's forming the bubbles out the top. And it's those bubbles, as soon as they get big enough to get caught by that sleeve, that's when they get lifted off the top and projected into the air. That is just blowing the liquid everywhere. This is not how it works in real life. It's a much gentler airflow. So I'm not sure about those little slots at the side in there, if they're partly for air ingress or liquid egress or both. It's quite odd. But I've never seen a bubble generating nozzle quite like this before. It's strange. It's fairly unique to that type of product. It must have taken a lot of research to actually get the airflow and the liquid flow correct, particularly when integrated into this small assembly here. It must have taken quite a bit of work indeed, and it really is quite, it's a low mess device. It doesn't drip. It does exactly what it says on the packet, no spill. Well, if you tip it upside down, you'll get drips. The bubble solution itself, now, when I was young, bubble solution's been around a long time. You know the little bottles you used to get with the bubble wand? And the first bubble solutions were fairly weak. It was just a surfactant, which is a surface active agent, which is it's a molecule that will bond to water and oil. It's sort of a dual function thing that, because there's no oil around, the oil would kind of disrupt this. It forms sheets of the little molecules stuck together, and that's what creates the bubbles. But latterly, because they weren't that strong in the early days, the bubble solution is like basically 99% water and 1% surfactant or somewhere in that region. But latterly they added a polyethylene polymer to it, which if I say J-lube, some people may recognise that. It's a veterinary lubricant for exploring animals' rectums, and indeed exploring human rectums for some people. But it actually creates a much stronger, it changes the structure of the water and it creates really strong films. And most bubble solutions use a small quantity of things like that to actually make the bubbles stronger. And you can actually, when that first came out, the advertising lingo was just saying bubbles so strong that you can hear them pop, and you could. They made a really loud pop when they burst. Big improvement in bubbles at that point in time. So there we have it. It's a simple thing, relatively simple. I mean, that must have taken a lot to design. With the airflow, the peristaltic pump, and then this strange cone with the outer airflow around it that just lifts those bubbles off as they form. It's a very clever design, actually. It's very neat indeed.